In this video, we're going to begin to look at the division of a complex number by another. Okay, so let's start with two complex numbers, Z1 and Z2. And we're going to look at Z1 divided by Z2. Okay, now we can write that as Z1 divided by Z2 times over here this object, which is the conjugate of Z2 divided by itself. So really this object here is really just 1. We're really just multiplying by 1. So we haven't changed anything. It's Z1 and Z2 times 1. The only difference is, being the conjugate, this allows us to undertake a process called realizing the denominator. When operating with surds, we have a process for rationalizing the denominator. Well, when working with complex numbers, we have a process that realizes the denominator. Okay, so let's take as an example, let's just say we have Z1 divided by Z2, and Z1 is 1 plus 3i, and Z2 is 1 minus i. Okay, what is the result of that division? Okay, well, what we can do is we can take 1 plus 3i and 1 minus i and multiply it by the conjugate of the denominator. 1 plus i, the conjugate becomes 1 plus I over 1 plus I. Now this is 1 plus I divided by 1 plus I is just 1, so we haven't changed this, but what it will allow us to do is when we work through the algebra here, when we work through the operations of multiplying the denominator, we're going to end up with a real result at the bottom. Okay, so let's multiply across. We have 1 plus 3i in the numerator times 1 plus I, all in the numerator, and in the denominator we have 1 minus I, times 1 plus I. Okay, so let's work our way through that. Expand out the parentheses. 1 plus I plus 3i plus 3 times I squared. And you remember I squared is equal to minus 1. Okay, and so that leaves us with, underneath we have 1. Okay, 1 by 1 is 1. 1 by I is 1i. Minus I times 1 is minus I. And minus I times I is minus I squared. Well, this plus I and minus I are going to cancel out. I squared becomes minus 1, minus 1, minus 1. Okay, so we have 1 minus minus 1, which will give us 2. And on the top, we will have 1 plus 4i minus 3. So that'll give us minus 2 plus 4i. All right, so minus 2 plus 4i and 2, divide through by 2, we have minus 1 plus 2i. So that's the result of that division. I'll just get rid of that. So we have, through this process of realizing the denominator, we've been able to come up with a complex number, a meaningful result for one complex number divided by another. Let's have another look, and let's have a look at another example. So if z is 7 minus 5i, then z minus 1 is 1 over z, so that's 1 over 7 minus 5i. Okay, again, we can realize the denominator by using the conjugate of the denominator, so 1 over 7 minus 5i times 7 plus 5i, the conjugate, over 7 plus 5i. Remember that divided by that's 1, so we're not changing anything until we actually expand through. Okay, so what we have is 7 plus 5i on 7 minus 5i times 7 plus 5i. All right, so top line 7 plus 5i, that's not changing. Underneath, expanding out the parentheses, so 7 by 7, 49. 7 by 5i is plus 35i. Minus 5i times 7 is minus 35i, so of course they're going to go. And then we're going to have minus 5i times plus 5i, which is minus 25i squared. I squared is minus 1, so that's going to result in a plus 25 there. We're going to have 49 plus 25 in the denominator, 7 plus 5i in the numerator, and let's add those together. So we have 7 plus 5i in the numerator over 74. Okay, if you want, we can break that down into a real part, 7 over 74, and an imaginary part, 5 over 74 times I. All right, let's go further. Another example, let's have a look at, I might fill the screen with this one. Here we go. Z is 3 plus I, W is 2 over 4 minus I, what is the imaginary part of 4z minus w. Okay, so first thing we need to do is we need to subtract these, multiply z by 4, and then subtract the complex number w from that result, and then find the imaginary part of that. So 4z minus w is 4 times 3 plus I minus 2 over 4 minus I. Okay, now let's find common factor here. Let's try to express this as a single complex number. So when we do that, common denominator of 4 minus I, which means we have to multiply the top here by 4 minus I, minus 2 over here. When we do that, expand out the parentheses, we're going to end up with 13 plus I, I've not shown the steps there, times by 4, minus 2 over 4 minus I. Well, when we do that, we're going to have 4 13s are 50, and plus 4 13s, 48. Take away the 2 will give us 50, and let's give it that 9 bit there. And so we have 50 plus 4i over 4 minus I. Okay, we need to go further. We need to produce a single complex number from the division of these two complex numbers. So we need to realize the denominator. Okay, well, let's do that. So what we have now is 50 plus 4i over 4 minus I times the conjugate of the denominator, 4 plus I over 4 plus I. Okay, let's put all that together over a single fraction bar or vinculum. 50 plus 4i times 4 plus I, 4 minus I times 4 plus I. Okay, well, let's expand out the parentheses. When we do, we have 200 plus 50 by 4, 200 plus 50i plus 16i plus 4i squared. All right, and underneath we have 4 by 4 is 16 plus 4i minus 4i, and then minus I squared. And don't forget that I squared is equal to minus 1. So what we're going to have up the top here is that's going to be minus 1, so that'll make minus 4 down here. So we have 200 plus 66i, 50 and 16, 66i minus 4. Underneath, again, these two will go, okay, and we'll be left with I squared is minus 1, minus 1 is, okay, 16 minus 1. Okay, that'll give us 17. So we've got 196 on 66i over 17. And we can write that as, we can split that into the real part, 196 over 17, and then the imaginary part, 66i on 17. And if you remember, the original question was to find the imaginary part of the complex number that was formed from 4 times z minus w. Okay, so we want the imaginary part. So the imaginary part of the complex number is 66 over 17. Okay, that is the imaginary part, 66 over 17. And that's it.